in this video, we are going to talk about what a logarithm is. But before we get there, let's talk about how we do some basic operations. If you had x plus 2 equals 4, you would tell me to subtract 2 from both sides because addition and subtraction undo each other, right? Well, if you had 3x equals 12, multiplication and division undo each other, so you would divide by 3. If you had x squared equals 9, well, exponents and radicals undo each other and you would take the square root. But what happens when you have an exponential function, such as 2 to the x equals 4? Now this one is easy. You could probably see that x is 2, because 2 squared equals 4. But what if you had 2 to the x equals 5? How do you solve that? Well, this is why we use logarithms. A logarithm helps us solve for exponents. So logarithms and exponential functions undo each other just like addition and subtraction undo each other. Now, it's important that we know how to say this. When you have a logarithm, the number on the bottom is your base. So we would say log base A of B equals C. Just like if you have this, we say f of x because it's a function. A logarithm is a function, and we have to say not log base A times B, log base A of B. So for example, this would be said log base 2 of 8. Now, it's really important to know that usually a base is written. So actually, I'll bring this back. If you had this, your base is 2. But if you see this, as in if you see no base written, that means that your base is 10. So these two expressions are equivalent. We're just too lazy to write the 10, and we call it a common logarithm. It's 10 because we have a base 10 system. We go 1, tens, hundreds, thousands, and so on. In addition, in math, we have a very special number called e. E is just like pi, where pi is 3.14, e is 2.718 approximately, and it's called the natural base. Now, mathematicians are too lazy to write log base e because that's 4 letters, so instead we write ln, only 2 letters. And these mean the same thing, but it is common and proper to write ln of x instead of log base e of x. And we call it the natural logarithm. That is not an I, it is an L. So the way we can remember this is we can go to our calculator, and if you take a look on your calculator, you see the log button. The log button to the left has no base. I know my base is 10 because I don't see it. Look right above the log button, how there is a 10 there. So I can know just by looking at my calculator, oh, log without a base is a base 10. And then look at the ln button. The ln button right above it has an e, and that helps me remember that it's log base e. So let's talk about how we actually convert between logarithms and exponential functions. We are going to remember the rule to keep the base and switch. So let's try it out. We are going to write these exponential functions as logarithms. So we have the base is always on the bottom. In this case, my base is x. So I'm going to write my equal sign. My base is on the left. I'm going to write log base x on the left. And notice how I put the x below the line because it is a subscript. It's kind of the opposite of an exponent. So I kept the base and now I'm going to switch. That means the 178 is going to come to the left and the y is going to go to the right. Let's try it again. I have my base b. B is on the left of the equal sign, so I'm going to write log with a base of b on the bottom on the left-hand side. I'm going to switch the other two numbers. So the 154 is going to come to the left and the a is going to go to the right. For the next one, I have a base of 10. It's on the left of the equal sign, so I'm going to write log base 10 on the left, except you don't have to write the number 10. So I'm just going to leave it as log. And now I'm going to switch. The p comes to the left, the m comes to the right. For the next one, I have a base of e. Now, you could write log base e. It's not wrong, but it's not proper. So instead of log base e, I'm going to write ln for natural logs. And I'm going to switch. The z is going to come to the left, and the x is going to come to the right. I swear this will make so much sense tomorrow when we use this process of converting to solve equations. But let's try going backwards. So we're going to start with a log and we're going to end with an exponential. I have my base x. The x is on the left. So I'm going to write x on the left. And I'm going to switch. The y is going to come to the left as an exponent, and the 191 is going to go to the right. I'm going to keep my base. My base is on the left side of the equation. So I'm going to write a big base n on the left, and I'm going to switch. The n to the 6 is going to come to the left as an exponent. The m is going to go to the right. For the next one, I don't see a base. When I don't see a base, I know the base is 10. So I'm going to write the 10, keep it on the left, and switch. The t comes to the left, the s goes to the right. The next one says ln. You need to know that ln has a base e. ln is on the left, so I'm going to write e, my base, on the left. And I'm going to switch. The r is going to come to the right as an exponent. The q is going to go to, I think I said that backwards. The r comes to the left, the q goes to the right. So this is how we convert. You just need to remember, keep the base and switch. If you're starting with an exponential function, you end with a log. If you're starting with a log, you should end with an exponential. I hope this makes sense, and we're going to use it to solve equations tomorrow.